Hello everybody, hope you guys are doing well. So today we will be continuing our journey with computer networks, and we will be starting with the first chapter of Frozen. That will basically explain us the different parts of networking, and then what is internet, why do we, what is ISPs, and so on. This is like an introduction to uh, introduction to internet networks. Now, objectives. This defines like what we will be learning. So, this provides a general idea of what we will see in the rest of the book. The one is data. The four concept that we discuss is data communications, networking protocols, and standards. Networks exist so that data can be sent from one place to another. Basic concept of data is the basic concept of data communications. To grasp to understand this fully, we must understand the communication components, how different types of data can be represented, and how to create a data flow. Now, data communication between remote parties can be achieved through called as networking. It involves connection of computers, media, and networking devices. So networks are divided into two categories: local area networks and wide area networks. These are two types of networks that have different characteristics and different functionalities. The internet is the main focus of this book. So basically, what he's saying that there are so internet can be subdivided as LANs and WANs. LANs is a local area network and WANs is a wide area network. The protocols and standards are vital to implementation of data communication and networking. Protocols is basically something, the set of rules that needs to be followed. Which is adopted by manufacturers and vendors. Models are basically to organize, unify, and control hardware and software so that they work in and align with each other. The term networking model studies the relationship to networking, and model also encompasses data communication. Okay, now first in this chapter we'll be learning about data communication and networking. We discuss data communication, data representation, and data flow. And this chapter 2 is where we start with the open OSI model or the uh, TCP/IP stack. Okay, now introduction. This is chapter 1. The data communication and networking and changing the way we do businesses and the way we live. Business decisions have to be made very quickly, and the decision makers require immediate access to accurate information. Why wait a week for the report from Germany to arrive by mail? That could almost come here instantaneously through networks. So businesses today rely on computer networks. So he's saying, why is computer network so important? So the advantage of using networks over mail is it takes time for mail to arrive. The development of personal computers brought about tremendous changes for businesses, industry, science, and education. A similar revolution is occurring in data communication and networking. Technological advances are making it faster for signal communication links to carry more and faster signals. As a result, services are evolving to use this expanded capacity. For example, established telephone services such as as and as things are going on increasing. As and as things are advancing, communication is becoming more and more important, and especially internet has been becoming more and more useful to us. Now, data. What do you mean by communication? When we communicate, is basically we are going to sell some information. This can be local. For example, if you are so I suppose if you belong to if you are a group of students, right? So local information will be only information that you that those the members of only the members of that particular group will have access to. So that will be a local communication. And then remote is something that takes place over, for example, I'm sitting in Canada and you are in some other country, maybe India. So then it's remote, right? So then communications happens. This is basically a remote communication. Okay, now communication includes everything, like it includes telephone, telegraphy, television. Now even now we have something called as IPTV, basically Internet Protocol TV, which means TV on internet. Gone are those days where we used to have separate connections for TV and then separate for internet. Now, what data refers to information, it can be in whatever form you agreed upon. So, what is data? Data is something For example, I and my friend agree to communicate in English. Now for us that is data, but then similarly for people, so for some other people that might be garbage. For example, computer can only understand machine code, right? For that it might be a garbage. So for communications to occur, first of all, what happens is I should be a part of the communication. That means I should be a part of the communicating channel. And second, they might be made up of a combination of hardware and software programs. uh, yeah, first criteria is the devices will be a part of a system that is made up of combination of hardware and software devices. The effectiveness of data communication, how effective the communication is, how fast the communication is, or how slow it is. So delivery is basically the time taken from sender to receiver. The system must deliver data to the correct. First is delivery. Delivery refers is it should be delivered to the correct destination. For example, if I want to talk to connect to someone who is in Germany, I should connect to a person in Germany, right? If I connect to a person in Switzerland, then it's no not it's of no use. Second is accuracy. Accuracy means um so if I say hi and the other person also gets to hear hi, that means the system is highly accurate. Whatever data you're sending, it is getting transmitted in the same form. That accuracy is timeliness. Timeliness means it should be delivered in a timely manner, right? For example, if someone is not well, so he has to be like he has to be medicated or he has to be hospitalized in a timely manner. If the time has passed, then there is no use of doing that, right? Same is for communication. It has to be a time bound thing. Jitter is basically a variation of packet time. Uneven delay, for example, when we are calling. Suppose jitter is basically when I am speaking and my video and audio are not in sync. That is jitter. So my video might come first, my audio might come last. That is basically a jitter. Okay, now what does a data communication consist of? A data communication basically has something called as first is a message. This message is the actual data or the information that we want to transmit. Then there will be a sender, there might be a receiver. There will be a transmission medium. Okay, and now both of them will agree to certain rules, right? Protocol is basically a rules that governs interpretation, that governs data communication, for example, and that might be agreed between two parties. So like if I and my friend agree that I'm using English, so then we will be following all the all the grammatical rules of the language English. Same is with communication. If you a sender and a receiver agree that they have to communicate, then they might follow certain rules or certain protocols. Okay. Now data representation. Data can be represented as text. Text can be bit. It's in lower form. It gets converted to ASCII using bits. ASCII is basically American Standard Code for Information Exchange. Then numbers can be represented by bit patterns or images. So images can be considered images as a large rectangular matrix where each matrix is basically a small square, right? And then that small square is basically contains a value that indicates the color, other contrast, clarity, other related things of the image. So greater those boxes, greater is the detail that can be captured. That's why a 1920 image is more high in resolution as compared to a smaller one, right? As compared to a 720p. Nowadays we have 4K resolution as well. So okay. Then audio is basically sound. It can be done using a microphone, as I'm using a microphone to communicate to you with these guys. Video is basically anything that is picture, no data flow. Okay, so the direction of data. Okay, so now communication between devices. This is basically simplex. So if two devices, if there is communication one way, then it is simplex. That is, it can go from one to another. Half duplex is the station one can send the data, and full duplex is bidirectional, right? Station 1 can send the data here, this station can send back the data. So here is only this is going to send the data, and then half duplex is going like both can transmit and receive, but not at the same time. So the medium will always be occupied. So it will be either one station one this station sending some message and then waiting, and it goes over here. Then this has the chance. Here and there is no waiting. Anyone can send, but here the problem is congestion. Okay, now networks. Now what is a networks? Now network is basically a set of devices, often connect and referred to as nodes connected by a communication links. For example, nowadays, what can I say? A network can be as small as LAN computers connected in LAN computers. Let's say in a library. It can be as so. This is a network. This is a network. This is a network, and then and there is no need to. There is no definition that it should be remote. Anything basically, any two devices connected to each other is a network. If you say in local language or a very common language, any two devices connected will form a network. Now okay, yeah, that should be capable of communicating. For example, I can send information from PC1 to PC2. They can communicate. Now, distributed processes. Most networks are distributed process in which a task is divided among multiple computers. So instead of okay, so what we're saying is distributed processes. Suppose instead of having one singular computer deciding which that takes care of all. For example, if you are in a company and you have given me a workstation, right? So what you will do, you will be assigned to a group, and then work will be distributed among that. Same is the case with processing. So instead of making one computer the head and say, okay, you decide which but here decision I mean is data is being transferred between which two computers, what is the protocol being used. So that all, instead of having a centralized thing, distributed. Network criteria. Network must meet a certain number of criteria. Performance, it can be measured in any ways, including transit time and response time. Transit time is basically from sender to receiver, and response time is the time elapsed between an inquiry and a response. The performance, like there are several factors such as number of users, medium, capabilities, connected devices, the capability of those networks, congestion, traffic, reliability. Reliability basically how reliable is the, in addition to accuracy, it's reliable, that the system should be robust, right? Even if there is a damage to anything, the data should still transfer. Security, again, one of the most important parameters, that no one else should be able to see what I'm transmitting. Yeah, physical structures. Before discussing network, we need to define some networks. Network is basically two or more devices connected to links. A link is a pathway that transfers data from one to another. For visualization purpose, you can imagine a line draw between 2 points. So then we're saying what is a point to point. Point to point is basically a dedicated link you have between a man and a boy. So a dedicated line. So basically we used to have those walkie-talkie type thing when you were a kid, like when you used to put one on the thing on one's ear and the other used to speak. So it's like a point to point. Multi-point is between which is more than two specific devices. For example, you have three people listening. Okay, so then what we will do at that time, since the channel is shared, we do time slicing. Okay, now first one User 1, this should get the data. Then user 2, then user 3 is called as time slicing, giving each user a specific amount of time. This is basically point to point single link. Main this is like multi-point, having multiple people connected to the same line. So then here we do something called as time slicing. And there are further categories: mesh, star, bus, ring topology. This is basically how networks can be generated. We would be diving deep in this, not in this line, I would say. As we go ahead, like this will become more clear. What is this repeater? Right now we don't know, right? Since we haven't studied anything much in detail. Oh, so now there are now what is models? So there are standards. There are two types of standards. One is the OSI and one is the TCP/IP. We will first study what is TCP/IP, OSI, why one is preferred over the other, and yeah. This is again a low level again network. You have a single main hub, and then you have different type of computers connected. So from here you can send the information to here as well. What is this? What is this device? What is this hub? This will be more clear when we go on studying further. WAN is a wide area network. There is different ways you can do ISP, modem. You have a computer connected to a modem. So we have some. So even in wide area network, there is two: a switched and a point to point. A switched WAN is basically so gradually we study what is this WAN and LAN. I don't want to make you more confused by going. So this is a mixture. Network engineering is basically to use a local area network and a wide. For example, now we have WAN is basically the ISP. It can be Roger, Shaw, whatever, Airtel, Geo, and then we have a router. So the modem is basic. So this is basically the gate, your modem or the router. Remember, nowadays modem have both capabilities, routing and acting as a demodulator and modulator. So then this is a local area network. Then again, this is then connected to something called as like server. Then you go to a modem LAN. Then okay, now what we talked so many things about internet, but we did not officially term what is internet. Now internet is a revolutionary experiment. It has affected the way. So yeah, post COVID, I guess. I mean, there was a sudden increase in the usage of internet because everything was shut down during COVID era. But it's still evolving. There are major sites like Amazon. Their whole product was internet on internet, right? E-commerce again. Okay, so yeah. So what does internet do? Instead of sending mails, waiting for a time to get a response, internet is something organized. We can with the help of the internet, we can directly uh, communicate in low time. Like there is no need for waiting and stuff. A brief history. Now, what is a network? A network is a group of connected communicating devices such as computers and printers. An internet in the lowercase I is two or more networks that can communicate. The most notable internet is called the internet, whereas more than hundreds of thousands of interconnected networks. Various organizations have their private networks. Then this extraordinary communication system. It started in 1969. So this is basically how was internet evolved. In the mid 1960s, mainframe computers in research organization were standalone devices. Computers from different manufacturers were able to communicate with, so it was basically advanced research project agency, basically US Department of Defense. So they were trying basically to have their computers at two locations communicate to each other without the need of uh, saving the file and then going and then loading it on the other computer. So instead of doing that, they needed something which could be done using which you can directly send information from one to the another. They were interested in finding a way to connect computers so that the researchers they funded could share their findings. They were reducing cost and eliminating. So basically, what they were trying to do is they were trying to establish communication. So there were some researchers who were trying to so they were trying basically to communicate with the researchers, and they were using a different medium of they were using different types of computers, and the researchers were using a different type. So they wanted something, some methodology using which, irrespective of the device, still the communication could take place. This is when ARPA or this was developed. ARPA presented its ideas for ARPANET, a small network of connected computers. This idea that each host computer, not necessarily is from the same fracture, would attach to a specialized computer called an interface. Message processor in turn would connect it to each other. So each MP had to be able to communicate with the MPs. Okay, so there will be like a central interface message processor, and there would be different computers connected to that IMP. The IMP would communicate with other IMPs as well as its own attached host. So then communication would have been made possible, right? Then in 1969, ARPANET was reality. It was officially developed. This is still present in the presentation stage, right? In 1967. Then later on in 1969, ARPANET was reality. Phone that the USC, that is UCLA, it's a trade school, and University of Carolina Center and Stanford Research were connected. So basically, the researchers, I mean, these were scientists, right? So they were studying at these universities. So they wanted to communicate at that time. I would say during ARPANET, when the initial presentation, this was basically during, this was after post World War, I guess. This was, this was the post World War or pre USSR, I feel. Is it, is it World War? Yeah, so this is during the Cold War period from 1960. So during Cold War was, if you don't know what Cold War was, let's see what Cold War timeline. Let's see. So this is basically it is, so 1945 is when World War II comes to an end. Then there is a power vacuum in Germany, right? So then the Soviet takes the one part, and then the other is given to the Allies. So in the Allies, US were the Allies. So then there was always a, what do we say? There was always some kind of war that was going on. Although all the countries had signed that there would be no physical war, but then this is war. This was basically war in terms of development, infrastructure, and any other thing. This is basically during the Cold War that the ARPA presented the ideas for ARPANET, a small network. Okay, by 1969, this was in 1967. See, within 2 years, these guys were able to have. So basically, these are different cities. Like this is located far away. Utah is another city. Stanford is in some other city, and California is other city. So these are remote locations, and now they could be able to communicate. In 1972, Vincent Cerf and Bob Kahn, both of them who were part of the core ARPANET group, collaborated on what they called Interneting Project. Cerf and Kahn's landmark 96, then they outlined the rules. How should package be transferred? So Then this paper on TCP included concepts such as encapsulation, datagram, and functions of a gateway. We'll study about it. Shortly thereafter, the authorities made a decision to split TCP, so it became TCP IP and IP. IP would handle datagram while TCP would be responsible for higher level functions. Now internet has come along, so today's internet. Here we come. What is segmentation, datagram? This all we will learn when we actually dive into the actual layers. Okay, now internet has come as a long way. In 1960, the internet today is not a simple hierarchical structure made up of many wide and long joined by connecting and continuing devices. It is difficult. Okay, so now we are in current era. Now internet is not so simple. What he's trying to say, it's like um, it is made up of many wide and local area networks joined by connecting devices and switching stations. It is difficult to give an accurate representation of the internet because it is continuously evolving. Networks are changing, addresses are being added, networks of different companies are being removed, so it's very hard to define today. The most individuals who want internet connection uses the services of ISP or internet service providers. There are international service providers, national service providers, regional service providers, and local service providers. The internet today is run by private companies. So, yeah, you remember ARPANET was developed by Defense, right? That is a government organization. Then later, now it has become privatized. So, like how you have ISPs. So, first you have the national ISP. That this national ISP will receive internet from the submarine cable. Then you have regional, and then you have local sharing. Uh, sharing the international service provider at the top of the hierarchy of the internet that connects nations together. The first, so ISPs are basically the ones who these are international internet service providers. No, these are not. These are the topmost people. So you have something called as international internet service providers. Let's see what is this. Then well-known hierarchy, like how this works. For example, AT&T. Now this is nationwide, right? I mean, then we have Deutsche Telekom, China Telecom. India, it's I don't know what is NTT again. Come Rakuten. These are what is in India? If I say India, so major services providers are. I don't want ISP. I want international ISPs. So NT, this is international, right? Its presence is global level. Like they have the largest ISPs over all. It's a very big this. The national internet service provider. The national internet service is the backbone of networks created and mainly specialized by companies. There are many ISPs operating in North America. Some of them are Sprint-Link, UINet, Internet, Mail to provide connectivity between end users. These backbone connected by complex switching stations normally run via the third called as a network access point. Some national ISPs also connected to another private switching stations and pairing point. This normally operate at a high data rate up to 600 Mbps. Okay, so then national internet service. Now there are some called as national ones. For example, in Canada, I guess national ISP in Canada is Rogers, and these are major players like Rogers, Bell, and Telus, I guess. Also, national ISP. So one is Rogers, other is Bell, then Telus again. It's a it's a national ISP. It operates at a national level. Now regional basically specific regions. They use the backbone and infrastructure provided by these national players. For example, I guess there is in Saskatoon there is Telnet. Telnet and Rogers. They have a partnership. They use Telnet uses all this infrastructure, I guess. No, um, some regional ones I want to say. Regional again Fido. Regional ISP use browser network or larger infrastructure. Fido is well version again uses. Yeah, Fido is that uses Rogers. There is Chatter that again tech savvy. Yeah, tech savvy. Yeah, I missed the name. Tech savvy. Again, this is using Rogers infrastructure. Then same we have there are other Primus Canada, Distributel. These are VM Media. There are so many. These are regional, right? So what they do is these ISPs, the regional ISPs, they use the network of the what do you say the national level ISPs. By network means the actual cabling is done by the national level ISPs, and these are just using them. And they give a pay, like they pay rent to them. For example, you are staying in someone's apartment, right? You are not the owner, you're just renting. So kind of like. Then we have local internet service providers. Local is basically you come to your own connection. They can be connected to regional ISPs, national ISPs. Most end users are connected to local ISPs. Local is something that is local to your own network. So protocols. Now communication occurs between entities in different system and entity. But then the question you might be asking is how are these international ISPs working, right? I mean, there should be something like a physical cable which is being run between the this international ISP, right? This is at the head, right? After you get go to the national, the international internet service provider. So then, I mean, then how does communication? I would say you need two places to be connected, right? Um, so communication in Rogers in Canada will be local to Canada, but then this is now how it works, right? We always want to communicate to people who are outside Canada, for example, in Germany. So then how are these countries connected? So there is something called as submarine cables. Now if you see here, these are basically underwater sea cables which are connected. Um, for example, let's see. Oh, so yeah, so US has so many of these. These are underwater sea cables which are running, and then uh, there's something called as where 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 you have where it ends is basically it's marked. See, yeah. So landing points are basically where it meets the shore. So you can see.